Okay, so everybody's got this version of the Module 8 quiz rational functions review, and numbers 1 through 8 are simple rational functions. And so that's why graphs are included on this first 8. So that you can experience what it looks like when a simple rational function is graphed. So the directions say identify the vertical asymptotes, and I believe those were blue through all our lesson plans, lesson talks. And the horizontal asymptotes, I'm going to go ahead and color pink, because that's the Y guy. So, more or less, the Y guy. So I will show you where they live in the equation so you can find them on your choices. So if the denominator says x minus 4, then the vertical asymptote is x equals 4 because it's what makes the denominator 0. Then our horizontal asymptote is the k number. Remember ABHK? There's just the k. We can count on that being a whole number on these first 8. And so that is your horizontal asymptote. And that's your first 8. Now there's more to the dance than this, but for number 1's dance, all you have to do is look for a pair of asymptotes. The vertical is x equals 4, the horizontal is y equals 1. So A's out, B's out, C's out, and D is it. Okay? So if you want to make that, sorry, it's really small. There we go. Won't color code much. I just wanted to get you in the game, okay? What you're looking for? This one was the pink line. This is the blue line. And because there was no negative in front of the fraction, the rational function, then it lives in regions 1 and 3. So you always want to make sure, just in case they sneak a graph in that doesn't match the asymptotes, then you want to know it's in the right regions. Does that ring a bell from 8.1? Even though you guys had all your work deleted, you experienced it, and you can always go back and experience it again. So now you know what to look for. So let's do it. Number 2, that's a good one, because there's nothing being added to x, so what's going to make the denominator 0 is 0. The k value, which is normal, y is 1. Now here's the, I'm going to make this guy green, I think. I can get my green highlighter that's not too dark. Here we go. This guy right here. Remember, he flips the function. So that means it's going to reside, the curves are going to reside in regions 2 and 4. And it looks like A is it. It's got the x equals 0, y equals 0, and living in regions 2 and 4. So you didn't have to look very far. And you look at the other ones, they don't have the correct vertical and horizontal asymptote. Okay, that's complicated as it's going to get for these first 8. You're ready. We got number 2 done. So I'm just going to go right to the vertical asymptote, horizontal asymptote, and there is no negative in front, so it's regions 1 and 3. So I'm pointing at nothing. Right, correct? Yep. It's a positive number there. So you look for values, D, and make sure it is in the right regions. And if this seems easy, easy is earned. Remember, you guys hopefully have wrestled enough with rational functions. You know why this is true. Vertical asymptote means that denominator cannot be 0. And horizontal asymptote is because there's always going to be a fraction added to 2. So this is a great example because it appears to be nothing, and see they're tricking you on nothing. They give nothing as an option, but there is something. Remember, what will make this denominator 0? X equals 0. And what's being added to this fraction? Y will never be 0. Crazy, huh? So we're shooting for that. It's a positive fraction, a positive rational function, so it's C. Positive makes a 1 and a 3 region. So they're going to mess with you. Obviously, if you look at the graph of A, it's not a rational function. It doesn't have asymptotes. So they're going to cast doubt on your knowledge. So be aware of that. Okay? We'll use the sticky notes for the last 8. That's what they were for. If you're thinking, what's the sticky note for? That's what's coming. Okay, coincidentally, 5 is the same story. The asymptote is x equals 0 because x can't be 0. The vertical asymptote, the horizontal asymptote is y equals 0 because this will always be a value. So y will always equal something that's not 0. So, oh man, didn't have to look very far for that one. Isn't that interesting? 1 and 3, no negatives in front. Wonder what the difference is. It just, let me see, that's like a multiplier, so it was like a vertical stretch of the parent function, if you were thinking about that at all. That's the only transformation, is that multiplier of 3. 6, we have a vertical asymptote of x equals negative 3. Horizontal asymptote of y equals 3, bless you. And we are in regions 2 and 4. I put the x down below because it goes with the denominator, so I'm being dramatic on that. That's why. And the y is out to the side. So let me see. I got to go in regions 2 and 4 and negative 3, 3. So A's out, B's out, C's crazy, B is it. This is region 2 and region 4. They're technically not the quadrants themselves because of the transformation, but that's a simple way to describe where they live, the curves. Okay, almost done with the simple ones. They're ready. We don't have very many. No, not too many tricksters here. Oh man, is that like a... Nope, they have a different sign. As I say, it almost looks like number 6. So X is a negative 3, Y is a negative 3, and it lives in regions 2 and 4 because it's reflected across the Y-axis, the X-axis, because it's multiplying to Y. Okay. They're both negative 3. It looks like A is it. Lots of A's. That's crazy. 2 and 4. Wonder what the chances are we get so many A's. I think it's just right now. Just happen to be a couple there. And you can look at the other ones and see why they're not. Here is a X equals negative 2. Don't forget to change the sign. But Y stays the sign. And looks like it's B. No reflection on the equation. So no flipping of the curves. 1 and 3. So that's what you did in 8-1. If you're ready to go on, we'll go to 8-2. A little more complicated. So number 9 through 16, there's no graph. Like I promised you, we got to find all the other parts. We are complicated. You're thinking, how can I do this without the graph? You can. We'll just identify the parts from our equation. That's where the sticky notes come in. Okay, complicated rational functions. That's what we're working with. Now we know how to graph them. After this lesson, then we'll learn how to solve them as equations. Yes. So don't put your factoring hat away. You don't need it. Okay. So number 9, we're going to factor first. So the reason we need to factor is because out of those factors comes wholes and x-intercepts and or vertical asymptotes like that. So that's why we need to factor. Now this guy has a 2 in common. So that leaves me x squared minus 4, and hopefully you are cognizant of this needs factored one more time because that's still a difference of squares. So now I rewrite my final denominator as 2x minus 2x plus 2. Scratch that one out because I'm done with it, and then I go looking for things. So even though this isn't the first on the list, I like to find the wholes first because they change my thinking about the other characteristics, because if it's a hole, it's nothing else but a hole. Now they just have the x value found as -2. Then I go back and find my vertical asymptote. I'm going to be very abbreviatic here. That comes from denominator. Ooh, I'm making my blue dark, sorry. So that's the other one. It's not a hole, but a line, x equals 2, because that's what makes the denominator 0. Then they have us do the horizontal asymptote. This is the one that gets, for me, it's the most confusing, because it's three things it can be. It can be a value, it can be 0, or it can be none, depending on the powers in the original equation, okay? Because these powers are the same, I can take these leading coefficients as a ratio and answer this question. Let's y equals 1/2. Okay, you see where I got my 1/2 from was the numbers in front. I think we colored those pink, right? Something like that, anyway. Because if you did the division, your quotient would be 1/2. But you can only do that when the powers are alike. Things change if those powers are not alike. Division is different. Okay, and then the x-intercepts. I need to zoom out on this just a little bit so you can see. Well, I guess if you just saw my sticky note, that's enough, so I'll leave it here. Okay. I don't know if we had a color for this. X-intercepts came from numerator, so x equals 4. So what do we make that a green, I guess? That guy a green. It's from there. And they do have a domain listed, but it's the result of the holes. Oh, no, that isn't how they write it. They don't write not equal. They say all reals except. Sorry. This is not like the homework. You had to write it in 3 different ways. This is another way you can write domain. All reals except these two. That's where they get their numbers. 2 and -2. So the domain can't be 2, and the domain can't be a -2. So those will match. So you've got your evidence, and you look through your choices. And the one that sticks out to me is the horizontal asymptote is a fraction, and I'm just looking what I haven't covered up. D doesn't have a fraction there. C has a fraction there. They have the holes as a -2. I have these two switched from the list, right? So holes a -2. Yeah. So C is the only one that has everything and the fraction for the horizontal asymptote. Vertical asymptote was 2. A hole was a -2. Horizontal asymptote was a 1/2. X-intercept is 4. Domain is all real, except for those two numbers there. Remember, these two match these two. So if you want to color code just this one, you don't have to color code every one. Just know where you got the information. So factoring is probably going to be the hardest part. And then if you've got your, game plan where you find the others, you should be good. Where to find them, where to find the answers. So I wouldn't look at the choices until you've got everything all figured out, because they're going to confuse you. Whether they're listed like this on a paper copy or if they're listed across on the screen, you're going to get lost. So take your sticky note, factor first. My numerator's got an X in it. So I get to factor that one more time. There's still a trinomial can be factored. My denominator has a 2x in it. That one's good. So this one is factors of 2. When subtracted, give me 1. And so the 2 is negative. So I just have my final numerator. Are you ready to play the game? I see a hole where x is 0 because there was a factor of x in numerator and denominator. Remember, here is the vertical asymptotes. I'll just call them VA. I try to spell it out. It gets confusing. Always in the bottom. Oops, sorry. My HA is tricky. Okay? Did I say tricky? Okay, here we go. Because the power of the numerator is 1 larger than the power of the denominator, this guy has a slant asymptote, just like the homework. Therefore, there is no horizontal asymptote. You didn't have to say what the slant one was, thank heavens, but because you'd have to take extra time to divide, but at least you know when the power in the numerator is higher in the power in the denominator, we have a slant asymptote. It fooled me. 5th period fooled me. Okay, alrighty. Now we've got to do, let's see, with the holes vertical, horizontal, asymptote, got it. X-intercepts. They come from up here. X-inters. So you take the other 2 factors, and that's where the graph will cross the x-axis. So x equals 2, x equals a negative 1. And then the domain, of course, follows with these 2. I think, well, that's kind of an I and an A and an M. It's not supposed to be an M, it's supposed to be an M. Domain. Oh, pickles. Okay, so we're all reals except, I got to leave a little corner on my paper, 0, 1. Because I got them from up here. And you can obviously see it is letter D. Everything matches. Holes, vertical, none, 2, negative 1, 0, 1. Okay. Fun stuff now, right? We got this? So factoring it is. Every test is a cumulative test in math. Got to remember how to do it all. Yeah. Okay, numerator does factor out nice once plus 4. All pluses. That doesn't happen very often. Now this one's kind of a sneaky snake. You see the -3 up front there? That is shouting to you, factor out a -3 if you can. So if I take a -3 out, sign switch. That's an x squared, that's a minus x, and that's a -2. And obviously I'm not done yet. So it's a -3 times factors of 2. When subtracted, give me 1. And it has to add up to a -1. So the 2 is negative. So it doesn't look like anything's in common there. So no holes. I'm doing this to make sure that I know what to do with the horizontal asymptote. And here we go. So the holes were none. I'm going to go ahead and put that first because I always do that first. Then vertical asymptotes come from denominator. Horizontal asymptote, I'm allowed to take the fraction in front here, -1/3, because they had the same power. That's why. X-intercepts, numerator. I guess they just list them, don't they? X-intercepts, yeah, they just list like, they don't say X equals. They just list -3, -4. Yeah. That's good. I was going to say, that is not the right one down there. Okay. And then the domain. All except up here. 2 and -1. I don't know if they'll have it in that order, but it's all reals except 2 and -1. I'm getting really shorthanded. Let me see. D is wrong because the vertical asymptotes don't come from the numerator. I'm just working myself back up. C. Nope. B. Nope. I found one. Thank heavens. I was getting nervous. A. A it is. Everything matches. And it happened to be the only one with that horizontal asymptote. So that helped you know you were spot on. Or number 11. Always there. 12 is a tricky wicket because there is no x's in the numerator. Therefore, there are no x-intercepts. Because I need a numerator to solve for x in order to find the intercepts. The intercepts are what makes the numerator 0, and there's none. So since this is a one-time fraction, I'm going to forego the sticky note. We could just factor that. X minus 3 times x plus 2. So if there's no x-intercepts, let's see, there's a couple of them with that, so we're going to keep on going. Okay, vertical asymptotes. No holes, obviously. X equals 3 and x equals -2. Can't see what I'm doing there. The only one that has that is D. Right? A doesn't have enough. B doesn't have any. C doesn't have any. So D is the result. There we go.
What are you
Oh, okay. They have to have matching factors like number 9. See how these matched?
So they have to match the signs of numbers?
It has to be, yes, it has to be the variable at both the top and the bottom, numerator and denominator have to look just alike. Okay, and we had that one and we had number 10 where we had x and x from numerator to denominator. Otherwise, there are no holes. For 11, there was nothing that we could like cancel if we could, but we don't ever want to cancel because they're part of the polynomial story. We just noticed that. Okay, so that's why holes. And then the horizontal asymptote was because of the power. The x, it was 1 over x squared. And I can't take x squared times anything to get 1. So that it's the quotient is 0. Bless you. It could be 1 over x squared, 1 over x to the 4th, 1 over x to anything. If there's a constant in the top. And we already talked about why the x-intercepts, because of the 1. There was nothing to solve for in the numerator. So you could make that note. No x in numerator. That's how we knew x-intercepts are none. Good question. Thank you for asking. And these two come from these two. They just switch them around for whatever delightful reason they want. Crazy, huh? I guess to give you flexibility. I want to make you flexible. So if you see where the horizontal asymptotes, the rules change depending on the powers. That's the hardest. For me, anyway. Think. Stop and think. I would rather just do. Okay, since this is a simple factoring, I'm just going to write it down. 1 over 2 times x minus 1. So there's no holes. The vertical asymptote is x equals 1. I need to put a colon instead of an equal sign. The horizontal asymptote is y equals 0 because the power of 1 is higher than the power of 0 because this is, x. The x that isn't there is really x to the 0 power. I'll go ahead and write the holes are none. X-intercepts none. Oh man, I gotta get over that. Colons. Because of that, up here, no x-intercepts. The domain comes from the asymptotes. Ah, tricky. This is a complicated function. So, number 13 is A, but why don't they say 0 for the domain? Because of the not simple. So that's why I was wrong. And I don't know if you remember that from yesterday on the graph of that one function. When you graphed it, there was that middle curve, it went like that. There was a curve that went like that, and curve that goes like that. This guy is the one that made 0 possible for the domain. So I don't know if that's how this one looks on the graph or not, but there is a reason why 0 is not included. Because there's no other choices but A with all the other characteristics. So that's good too. You can get into, most of them are right, and if none of the others match at all, you know you're right. That was a tricky one. Usually I'm assuming the domain matches what they have. So. Oh, I see what I'm doing wrong. It's supposed to be from these two, not this one. Okay, so. Yep, there was no holes, so we're good. I looked at these two for my domain. Ooh, look at those two. So my mistake. Okay. And that's okay. Okay, 14 is just a couple of factorings, so we don't have to factor twice. So we can go ahead and put our 2 factors on our paper if you like it that way. Otherwise, keep using sticky notes. That's fine. In x, I need a positive 1, so it's +2, and a -1. How's your factoring? Okay, vertical asymptotes. I'm going to go ahead and color again just so you can see on this one. See how there was a couple of choices? See that, guys? B and D, or I'm sorry, A and D. Let me zoom out. Have that 2 choices. Let me get zoom out. Oh, don't disappear on me. So we got to keep digging. Okay, the holes were none. That's true. So they're still, both are in the ball game. Okay, now, the powers are the same, so I can divide. 1 divided by 1 is 1. So that's why A is the answer. So that was pink, right? The powers are alike. You do division and find the right horizontal asymptote. X-intercepts come from up there. We're good. And the domain came from the vertical asymptotes because there were no holes. Is that coloring coming in? Yes. Oh, how do you factor? You've got to know your basic facts, and then you've got to know if I FOIL these guys back out, I would get my answer. So that's how I can count on I factored correctly. Okay, if I would have got a sign wrong down here, if I would have had 2 pluses or whatever, or 2 minuses, then I would have not gotten back this polynomial. So do you know how to FOIL? Like first 2, after 2, inside 2, last 2, one play? That's how you can get better at factoring. You guys want 15 and 16, or you want to wait till tomorrow? Tomorrow. Okay, thank you. After our reading, before our work day. I'm going to pause. Is it working? Okay, here we go. Number 15.
Let's go.
All right. This is a complicated rational function. Yes, so that's why we're looking for all these parts. Okay. You got your sticky note?
Yes.
And we're going to cover it up so it doesn't distract you. All right? Don't be distracting, please. Okay, the key to these complicated functions is to factor first. So this function, the numerator is already as factors as it's going to get. The denominator, I can take a 2 out. Correct? You agree?
Yeah.
See the greatest common factor of 2? It's kind of bright, you think? Looks too bright? Should I change the
No,
lighting?
it looks good.
Looks
Oh,
good.
whoa.
See, that made it,
There we go. There. Oh.
it needs to come back just right.
Boom.
There we go.
Boom. Boom.
Okay.
On the spot, miss.
So I'm going to use some
Right in there.
abbreviations, but they'll be clear. Okay. VA stands for vertical asymptote, and we find that in the denominator, correct? So whatever makes the denominator 0 determines the vertical asymptote. Okay. The next one they have on the list is wholes. And wholes have to come from matching factors between the numerator and denominator. This is the factor in the numerator. Is there any of them in the denominator? No, so there's no wholes. So they say none. Okay, wholes. Okay, now the horizontal asymptote is what y is equal to. And these rules change every time there's a different circumstance between the two numerator and denominator. So you've got to go back to the original function, and if these two are the same, like this is x to the first and that is x to the first, I can just take their leading coefficients and write them like a ratio. But I can only do that if the powers are alike. Can't do that if the powers are different. It's a different rule. It's all about the division. Okay? Because x goes into x evenly, then we get the result of 1/2. So that's the reason the horizontal asymptote is y equals 1/2. Okay, the next thing they ask is the x-intercepts. And they come from the numerator. I'm going to go ahead and the x-intercept comes from here. It's what makes the numerator 0. So they just list a value. They don't say x equals or anything. They just list the value. And I didn't notice that until I got into the examples, whatever. What is the value for the x-intercept? 4. Yep. So that's the way they put it. Okay. But x equal 4 is fine. The ordered pair 4, 0 is fine. There's several different ways you can describe an x-intercept. Okay. Because you know it's on the x-axis. That's why you can be kind of wiggly with how you write it. Okay, the domain, they wrote a little bit different. Instead of making set notation or inequality notation or interval notation, they used words. So they said the domain is all reals except what makes the vertical asymptotes or the wholes.
1.
Yeah, you got it. So that's where they get the domain. The domain comes from, yes, yeah, vertical asymptotes and the wholes. Then there would only be the vertical asymptotes listed. Fair and square? Okay, so
freaking circle.
let's look. D is looking a very good match, isn't it?
Yes.
Yeah, everything matches. So we're going to pick D. Because we're right. If you look at the others, there's going to be something wrong. Something is missing. Some of them might be wrong. This is the most difficult ones on the test.
Too difficult.
But if
Do
you
we take
can
it
do
off the
this,
test?
if you,
Let's just take it off the test.
no, this is from the 8.2, so I can't take it off the test. Okay. Yeah. All right. What's that? No, it's done deal. It's in cement now, guys. I printed it off for those who want paper copies, and it is on the CUDA. Yeah. Yeah. It's called preparation. I don't want to kill any more trees. No. Okay. Yeah. Okay. So what do we say to do first? Factor first. Yes, yes. So 2 is factored, right? So factors of 2 when subtracted give me a positive 1. Two and 1. And which one gets the plus sign? 2, yes. Very good. The larger factor always gets the middle sign. Yay. Good job. Okay, now we're ready to talk. Vertical asymptotes. Yep, because they come from denominator. Okay. Any holes?
Big one.
A big fat nothing. Remember how to get a hole? Okay, it's got, if this factor on top looks like a factor on the bottom. So there are no x's on top that look like the x factors on the bottom. No, none.
Oh.
So when you see one, you'll know one, but 16 doesn't have one. Okay, this is the most difficult. Horizontal asymptote. You see how the power in the denominator is greater than the power in the numerator? Yeah. Okay. That means if I divide x squared into 2, my quotient is 0 because I can't take anything times x squared to get the number 2. So that's what happens when the denominator's power is larger. X-intercepts. Okay, that comes from the numerator, and since there are no x's in the numerator, there are no x-intercepts. So if the numerator has no x, this graph will not cross the x-axis. Interesting, huh? And we can tell it from the equation. We don't need the graph. Okay, there are no holes, but there are 2 exceptions to the domain.
Negative 2 and 1.
-2 and 1. Yep. So see, you can do it one at a time. So D is out, isn't it? It doesn't have matching things.
C.
D is wrong. Which one? C? Okay. -2, 1, none, 0, none, all reals. You got it. You got it. Okay, that's good. I think they'll catch that one on the camera.
Let them know.
It's got a good speaker and you're close. So listen to yourself tonight, okay? Thank you.